Research and Development team will share their experiences as part of the Early Adopters Program for SPOT, Boston Dynamics Semi-Autonomous Robot Dog. This session will focus on using SPOT for automated reality capture and the use of spatial data for digital twins. Please, if you have any questions or reflections, write it down on YouTube chat or Discord, and we will reply. Actually, I can't wait. So welcome, dear friends and colleagues from Fosters. I'll invite Khaled to start this amazing event. Welcome, Khaled, on board.
Thank you, and good afternoon, everyone. Thank you for having us today. I'm Khaled, and I'm joined today by Sherif and Sherif Tarabishy and Anders Rod to talk to you about some of our latest work. Just a small introduction. We all work for the Applied Research and Development team at Foster & Partners. We three come from an architecture background. Sherif and I graduated from as Architecture Computation Masters in the Bartlett UCL, where we are now tutors, and Anders holds a Master of Engineering in the field of architecture from the University of Tokyo. Today, I will first show you an introduction and some of the examples of the work that we do in the ARD group in Fosters in different fields. Then Sherif and Anders will follow with our latest project working with Boston Dynamics. So Foster & Partners, of course, is a renowned architecture office with more than 50 years of experience and built projects all around the globe on every scale, from furniture to pavilions, yachts, bridges, towers, airports, and cities. We are a global company of more than 1,200 people, and our group is actually small compared to the size of the office, but we cover like a lot of expertise, like from complex geometry to machine learning. We also come from different backgrounds, from architecture, engineering, and art. And the common theme between all of us that we are all programmers. Among us, we have worked on hundreds of projects. For example, the Swiss Re, the Mexico Airport, the Mobility Pavilion, to name a few. But today we'll focus more on showing you some of our research initiatives. So our group conducts research and innovation in several domains, including computational and performance design, driven design, simulation, optimization, machine learning, extended reality, smart buildings, and robotics. Through these efforts, the group brings the advanced technology out of the lab and into the hands of the designers. So we have been taking technology very seriously for a long time. This picture was taken 15 years ago. It shows a project called Arthur. In this project, it was a collaboration between our group and UCL, looking into augmented reality. And the hardware at that time cost like more than £100,000 per person. But this allowed us to test some of the use of like the design in augmented reality early on, but the technology was not yet very widely distributed. But because we investigated the possibilities of the technology so many years ago, today we're able to use augmented reality and virtual reality not only for visualization, but also for team collaboration and design. And this is very important because collaboration is a core part of our design process. The office's focus on performance-driven design and sustainability inspires a lot of the tools that we developed. What you see here is one of our bespoke applications to quickly analyze options and break down the barriers between physical and digital modeling. So, for example, we are tracking and capturing a digital model in real time, where you can manipulate it, you can change the location of the buildings, and at the same time get like an instant feedback of what the performance of this design might be. And of course, as technology develop, our bespoke performance-driven design tools also evolve. So, for example, now we're using gaming engines to develop our latest application called Sandbox, which is an interactive application that works like Minecraft on steroids, where the user can basically go in, create like design options, and analyze them in real time. And he can also run this application in multiple interfaces from touch to AR and VR. There is a variety of performance evaluation criteria that drives our design decision, and even more so when we are not just looking at the building scale, but also at the city scale. So from sustainability to investment models, there's a lot of things that can drive how we design urban spaces. So we bring the process of optimization according to these drivers, not just for buildings, but also for cityscapes. So for example, if you're having a road network and discrete buildings, we can instruct a computer to go through hundreds of thousands of iterations, running through a multitude of analysis, and at the end provide a solution space that we can check and find the best performing option out of it. Let's take this example. We look at finding a building layout that maximizes total area, views towards the river, views towards a point of interest, daylight potential, sunlight towers on the street level. And usually you would spend months and months creating and analyzing different options manually. But what we do is we actually use a genetic algorithm to create like thousands of generations of options, evaluate each one of them based on our simulation, and this allows us to basically cut short the process that can take like months and months into the matter of hours. And what we do here is we actually run it on a large scale cities, not only on buildings. But as I said before, innovation can be applied on all scales and all stages of design. So from the city level, I'll take you down to the material level, where in collaboration with Autodesk, we used machine learning basically to predict how a passively actuated material could react to temperature. So with the help of a tool we have in the office called Hydra, we run thousands of analysis to understand how these laminates might behave under varied heat conditions. We then used that data to train a deep neural network to tell us what laminate layering we should have given a particular deformation. So we kind of reverse the operation in order to be able to check our design intent first, and then figure out what materials, what layering we can have in the laminate material. Sorry, I skipped one. On the building scale, we use many complex analysis to validate design intent. One example of that is an analysis that measures connectivity from one point of the plan to all others. This is usually a good indication of how well the plan is performing as a co-working space, but usually it takes a lot of time to run. So we use machine learning to train a model that can predict the result of the analysis without the need to run the analysis itself. And this also is achieved by feeding the algorithm with a large number of pre-computed analyses. So on the left, you can see the result of the analysis. In the middle, you can see the machine learning prediction, the machine learning model for the same floor plan. And you can see the model getting better and better with more training. And in the end, we can have like a speed increase of almost 50x from running the analysis, from using our model rather than running the analysis. We also have big interest in robotics and in fabrication, looking into the use of industrial robots, and increasingly looking into the use of mobile robots like the Amazon Kiva robots, for example, to reconfigure architecture spaces, both in the interior and the exterior, which gets us to the main topic of today, which is the recent collaboration we did with Boston Dynamics. This was a group effort headed by Martha Tsigeri and Adam Davis, who are partners in charge of our team. And I'm happy to hand the stage to Anders and Sherif, who will talk you through the process. Now I hand it over to you, Anders.
Thank you very much, Khaled. So as Khaled mentioned, our group conducts research in several domains. With Spot, we saw an opportunity to bridge two of our domains. So that is robotics and digital twins. We wanted to explore a workflow that would allow us to quickly compare as-designed models against the as-built reality. Spot's ability to perform semi-autonomous consistent scans of our building sites can close the gap between the digital and physical state of a building. This can eventually create faster and more adaptive design to construction cycles. This is because constant and quick checks to monitor accurate and timeframes on site can be instrumental in integrating design and construction and allowing for further flexibility. Additionally, we have been investigating how these scans could be of use, not only during the design and construction process, but also when the building is operational. We see great potential in digital twins, that is, a digital representation of a real-world processing. This image shows the hub space on our campus. The hub is a flexible working and social space with a wide range of uses and constantly changing furniture layouts. Scanning spaces like this at a regular interval allows us to assemble a detailed timeline of the space. By creating and using this twin, we can visualize and simulate interactions between the designed space, occupancy, environmental condition, and energy usage. Smart buildings gather information such as air quality, occupancy, data that is useful to people who occupy and manage them. Our corporate headquarters in London is a smart campus with detailed readings of air temperature, other air quality measures, occupancy, and we're doing this across our estate and across seasons and years. Repeated scanning sessions allow us to correlate changes in the sensor data with changes in the physical fabric of the building and spaces. Putting it all together, we can begin to analyze how multiple sources of data interact. Here we look at a summer day and an early autumn day, comparing the change in interior and exterior temperature with CO2 levels and occupancy. The greater CO2 level on the right-hand side for a similar occupancy rate is due to lower ventilation because of the exterior door now being closed. Later in this presentation, I'll describe in more detail this kind of post-occupancy twin. Sophisticated, up-to-date spatial information is also critical for wayfinding. Here we see a three-dimensional wayfinding application for our main studio space in London. With the addition of environmental and occupancy data, such an application can help staff and visitors to find spaces appropriate to their intended use and personal comfort. Imagine telling a virtual assistant, I would like a cool space for a quiet meeting with two of my colleagues, and then just shown where to go. We are also interested in digital representations of the construction site and capturing how the construction progresses over time. My colleague Sherif will discuss these construction twins in detail later, but before that, he will introduce us to Spot.
Like Khaled mentioned earlier, we have always been interested in using 3D scanning on site. We met with Boston Dynamics during a conference and we started talking about the use of robotics on site. With our interests and vision aligned, we were invited to their early adapters program. At the time, back in February 2020, we were the only architectural firm on that program. Spot is a robot designed by Boston Dynamics. It's a four-legged semi-autonomous robot. And of course, it's also an internet sensation. You might have seen it with its friend towing at trucks, dancing on Bruno Mars, or even having a choreographed dance with its extended family. Spot is a very capable robot. It can maneuver tricky terrain. It is controlled by a tablet where you can set and control different features and parameters. It can move through the controller or autonomously. When controlled through the joystick, Spot's sensors are always working to assist you. The sensors allow it to see close obstacles on its way and adapt to them in real time. This complexity is not for you to deal with while you're controlling it. For example, on the video on the right, you can see, like in the controller, we're just pushing forward and Spot is navigating around the column on its own. Similarly, on the left, you can see it scaling the stairs in our office's entrance effortlessly while we're just on the joystick pushing forward. Spot can also be set free. You basically just press play, and it can follow a pre-recorded path on its own. We will cover this feature in depth later and see how we used it. All of those capabilities make it a very great tool to use on site because it can go almost everywhere a human can go, and even more places that a human can't. The obstacles it can overcome, we have seen other types of robots miserably struggling with. There are different things that you can pick and choose in order to customize your own Spot, from extra CPU compute or GPU compute, or even an extra robotic hand. Our setup specifically had a LiDAR scanner, which you can see in the front. This is similar to the one you might see on autonomous cars. And this scanner is only used by Spot itself to facilitate its autonomous navigation. The other accessory, which you can see on the back, is a 3D high-resolution laser scanner made by Faro. The one we were using was Faro M70 scanner, and we specifically used Faro at that time because Boston Dynamics had the most mature API integration with that specific device. More integrations were added later on with different manufacturers. Traditionally, the process when using such a scanner manually on site, the operator would start moving the scanner from one location to another. And at each point, they need to initiate the scan and then run and hide somewhere to try to stay clear from the line of sight of the scanner. And this is usually hard because it's 360 degrees. Then basically keep doing that until you have the whole site covered. It's even more tedious if you want to do that not just once, but multiple times throughout different time intervals. Once you acquire the scans, the next task is merging them into a single scan. This process is called registration. Anyone who did this, they definitely know how tedious it is. The reason being, once you load all the scans together, they usually look like this, a misaligned mess. Even though the multiple scans we see here are taken from the same space at different locations, the scanner doesn't really register the transformations that happen to the scanner throughout the space. So you might end up with a lot of scans sharing the same origin. Some recent scanners in the market are attempting to mitigate this problem. But if we go back to the usual process, once you have those scans loaded on the computer, you then start grouping them based on proximity or similar features appearing in the same scan. And what you do is you first attempt to align them automatically through the software provided by the manufacturer you're using. The success rate of this process isn't usually high. So you still might end up having to try and align things manually. In this process, you start trying to find different landmarks that are visible from different scans and start pairing and aligning those scans together and keep doing that until you have the whole amount of scans aligned together. Again, remember that our objective might not be doing this once, but rather doing it multiple times throughout different time intervals over different stages of the construction process. Spot, on the other hand, has a great feature where starting from a known location using a marker, the one that you can see on the wall on the left, you can start recording what we call a mission by manually guiding Spot through the space and identifying where scans need to be taken. While guiding Spot through the mission, it records its surroundings and its movement through the space. Later, you can ask it to repeat the exact mission over and over again as many times as you want, even when changes are introduced to its surroundings. On the tablet, you can see how it records, identifies, and matches obstacles, those colored. This should be a video. I'm not sure if you're seeing it or, yeah. So like you can see the colored points, and this is how internally it keeps track of the obstacles, matches them when it's repeating the mission, or updates them if it sees that something changed on site. And the arrows that, if you can repeat the video again, Khaled, sorry. The arrows that you can see, we call them waypoints, and they are showing its general intended flow within the space. During the route of the mission, you can tell Spot to stop and do a specific action at any point. In our case, those actions were usually take a scan. And because Spot is keeping track of all the transformations since the start point of the mission with the marker that we had, this data can be embedded as metadata in the scans and used to automatically align multiple scans from the same mission, or even scans from sequential replays of a given mission. And this is how it looks in comparison to the traditional process. On the right, you can see how loading the scenes from Spot with the embedded location metadata would look like. So now Anders will tell you more about how we've been using Spot and those point clouds specifically.
So in the most general sense, Spot is useful whenever we want to get four-dimensional information. So that is a snapshot of a space at a specific point in time, or when we do these repeated scanning sessions, how a space changes over time. But we might also say how time changes over space. How do decisions about construction facing issues affect the amount of time required for a particular operation? Or how do spatial arrangements of furniture, for instance, affect the amount of time that people spend in the space? And Spot's ability to gather spatial data at regular intervals is a big piece in this puzzle. We're describing these 4D models as twins, and for this project, we have grouped our study cases into the following two. On the left-hand side, the construction twin, which is the four-dimensional representation of the construction site. So here we are comparing a BIM model to how the as-built progresses over time. And on the right-hand side is the post-occupancy twin, which is focusing on how the physical space is being used. Here, the spatial snapshots from Spot are used in combination with other data sources, such as occupancy levels and environmental information. All in all, we managed to do more than 280 scans with Spot. So when we started this project, Spot was on version 1.6, and we were running into a lot of technical issues. But I guess that is just a part of being an early adopter. As a part of our regular meetings with Boston Dynamics, we were providing them with feedback about the issues we were encountering. So when we got back to round 2 in July and August last year, Boston Dynamics had been working hard on implementing a lot of our requested features. And we will go a bit more in detail about these specific changes later in this presentation. As for the case study for the post-occupancy twin, we decided to use this multi-purpose space in London, which we call the hub. As I previously mentioned, the use of the hub ranges from being a breakout space, a space for focused work, for lectures and social events. And the furniture arrangement changes accordingly and therefore gives us a variety of spatial configurations to investigate. As a part of a separate research initiative, we've been using this space as a testbed for smart building technologies. For this space, we have environmental data such as temperature, humidity, and CO2 levels, as well as occupancy data. Here, a research goal was looking for spatial insights by comparing the point clouds with environmental and occupancy data. So we were scanning the hub on different days with slightly different spatial configurations. The plan you see here is actually a plan view of a point cloud, and the yellow dots, that's the scanner positions. So if you take all the 8 yellow dots, that would be one mission. So during this time, as mentioned before, Spot was in version 1.6, and one of the limitations was that we had to do the whole mission in one go. So if one scan failed, or the robot got stuck or lost Wi-Fi connectivity, the whole mission would fail and we have to redo it all again. And this is one of the things that was addressed later in version 2.0. We decided also to do the scans in this space in the fine detail, as well as adding colors to these scans, where some of the scans on the construction side we could do with quicker settings. So on the construction side, we spend a bit more than a minute per scan, but here in the hub, we spend around 5 minutes per scan. As you see in the video, if we can get it playing, yes, here we go. Spot has a cage on the back that protects the scanner. And this is important specifically on the construction side in case the robot falls over to protect the scanner. But this cage actually occludes some of the points in the point clouds. Therefore, we want to try to scan without the point cloud here. We ended up first doing a test run where Spot would walk the route in order to ensure that Spot is able to detect all the obstacles, such as the furniture. Then afterwards, we remove the cage and then do the full scan. The first time we went to the hub in order to set up the mission, try everything out and get it working, I think we spent most of an evening. We left pretty late, but on our third session, that one literally just took an hour, which included bringing Spot, powering on the scanner, positioning Spot in regards to the marker, doing the test run, and then doing the 40 minutes fully automated scanning. So for these kind of repeated scanning sessions, Spot's automation features, they add a lot of value. What you see here is a comparison between 2 different dates. So it's a February date and a March date from last year. And one of the differences between the 2 point clouds was this presentation board that just disappeared now. That was only present in one of the 2 scans. And on the right-hand side, there's a flower vase that also will disappear. Again, it was only present in one of the 2 scans. And then all the way in the back, in the moment, you might see the silhouette of a person. Here you can see to the left. And this person is probably wondering, what is a robot dog doing here? Now Sherif will tell a bit more about how we've been using Spot on the construction side.
So with construction twins, like Anders just mentioned, we're interested in capturing specific processes and how they affect the progress of the construction site. We tested the process at Battersea Power Station on 2 different levels. They were at different construction stages. Level 7, which we see in front of us here, was in an early stage, so not much obstacles lying around, and it was a very simple process, recording the mission and going through it. Level 1, on the other hand, had progressed further. So rooms were already defined, mechanical equipment to be installed were already stored on the floor. So it was very hard to navigate around the space. As you can see in this plan, the definition of the rooms meant way longer missions for Spot because it had to go around a lot of different spaces, defined spaces. We had some challenging constraints in this case. The first was battery life. Back then we were using Spot version 1.6, and losing the battery meant basically that we had to start the whole mission again from the beginning. This was something that was later resolved by Boston Dynamics. The second issue that we were facing, we couldn't basically afford repeating the whole long walk again from the beginning if the last couple of scans fail for any reason. And again, it was an issue limited to Spot version 1.6. This led us to breaking down this whole floor into different scans or different missions. It was too much fun trying to troubleshoot problems on site when we had limited access to batteries and so on. And basically one of the objectives being part of the early adapters program was identifying all the issues that could be like we can face on site and communicating all of them to Boston Dynamics. After each mission, we ended up having a long list of feedback with problems and suggestions to Boston Dynamics, most of which were integrated in updates before we even ran a different mission. Once the lockdown started, we decided to move to something closer and easier to control than construction site like Battersea Power Station. We looked into tracking the progress of retrofitting one of the buildings that we have on campus. It's called 711 building. And we tracked two different levels, level 1, which we see here, and also level 3. It was the first time we actually managed to do a single Spot mission that has this number of scans, the yellow dots, which were around 17 scans. At this time, Spot software was now at version 2.0, and a lot of the concerns and problems we were facing previously that we already raised with Boston Dynamics were resolved. Mainly, stability has increased drastically. Most notably, we were now able to swap batteries mid-mission. Previously, if Spot lost battery power, it would just sit down and the whole mission would be over and you have to start it again from the beginning. But now what happens is Spot still lies down on the ground, but you can just flip it over, swap batteries, and you can press play and continue from where you left off. Similar thing was happening previously when we would have a comms drop. In this mode of operating Spot, you were still needed to follow Spot while you have the controller, and there was a connection that needed to be maintained between your controller and Spot. If at any point this connection is lost, again, Spot would just lie down and you lost the mission. You have to repeat it all over again. With Spot 2.0, this was fixed. And again, whenever that happened, you can just like walk closer once the connection is reestablished and you can continue the mission from where you left off. Over here, you can see examples from the different point clouds generated from around 5 missions on level 1 and 3 missions at different time spans that was done for level 3 as well. One of the problems we faced in this site included how some materials affected Spot's navigation. Like, for example, the ceiling panels with the fine holes in them, or the foil insulation for the ducts, or the bubble wrap and cables hanging from the ceiling. All of those things were communicated to Boston Dynamics to attempt and resolve as well. One handy feature in 2.0 was the ability to control the height of Spot for each scan. The lack of such feature caused us some problems in Battersea Power Station, And it was really helpful that it was added by the time we started working here, because as you can see, the whole plan is full of desks that were all at the same level as the scanner. So unless we were able to tell Spot to do a specific action, which is take the scan, but also at a specific height, we wouldn't have been able to cover the whole space. Another problem was obstacles added in later days after a mission was recorded. As we said, Spot can still maneuver around elements introduced to the site, and it did so amazingly well in Battersea Power Station. But in here, most additions to the space led to complete blockage to Spot's path. This is something that can be expected to happen in any construction site. So we started discussing with Boston Dynamics different ways of overcoming this. Like, for example, giving back control to the operator to decide whether to skip the scan. So basically what's happening here, that room at the very far end in the mission, it has a scan, and Spot knows that it needs to go and stand exactly in a specific place to take the scan, but it's not able to reach that point because of the things in front of it. And it keeps trying to avoid it, but there is no way to do that. So one of the things we would expect to happen here is for the operator to decide whether to skip that point that Spot cannot reach, maybe even take a scan from where it is and then proceed with the rest of the mission. And those kind of solutions were very important, especially if we're envisioning in the future that the whole process can happen completely in an autonomous way without the operator following with the controller. And this is something also that we will highlight later on. So once the data is gathered, we could perform as-built checks. For example, alignment checks, where we're checking the alignment between the point cloud data and the model, which you can see on the left. And we're highlighting overlaps between the columns and the walls that will need to be resolved or addressed somehow, but also deviation analysis between different point cloud data, so we can see how the construction of the site is progressing. All this is still manual and tedious and can take a long time to perform. And again, if you go back to the objective that we have here, which is doing this on different time intervals, it becomes even more tedious. And that's when we started looking in the market to see if someone already attempts to solve this issue. And whether we will be able to close the loop on this whole process that we're envisioning, or we will start to have to look like to develop something in-house to resolve that. And this is where Avir comes in. Avir offers an online service allowing you to automate the process of comparing point cloud data against design intent represented in your BIM model. In this slide, you can see the viewer, which is online, and you can upload your BIM model, again, representing your design intent, and then you can add multiple point clouds to compare against that BIM model. Over here, you can see some items flagged in red, which are displaced in the point cloud relative to their original location in the BIM model. And you also get your elements in the BIM model that had a deviation to the point cloud highlighted based on a specific threshold that you can identify. And you can get an automated report of all of those things, which can be communicated to different stakeholders to see how to address those changes. The whole process and collaboration was covered by different media outlets. And of course, thanks are due to everyone who helped us, whether inside Foster and Partners or from Boston Dynamics side. And of course, the biggest thanks are due for Spot. It was the one thing that suffered the most with us from slips in London, rainy streets, and falls on the stairs, but it always like got up and continued. Now we will leave you with a short video that we prepared highlighting this whole process, and then we're open for questions.
Here at Foster & Partners, we have been at the forefront of research for the built environment for over 50 years. We have teamed up with Boston Dynamics as part of their early adopters program for Spot, the semi-autonomous robot, to investigate how cutting-edge technologies can push the boundaries of both design and construction while enhancing productivity, efficiency, and collaboration.
3D laser scanning technology to capture and monitor on-site progress was integrated into a strategic plan developed by our Applied Research and Development Group.
This enables Spot to capture constant, quick, and consistent scans of construction sites. This precision monitoring tracks progress while still checking as-built versus as-designed models. Scanning and post-processing times have been reduced from weeks to a matter of days, while freeing up staff resource. Spot's remote control features greatly improve site visit safety and efficiency. Together with its ability to follow a pre-mapped route, Spot provides consistent repeated scans, navigates difficult terrain, and can access hard-to-reach areas on site.
This technology could be used to create four-dimensional models of our buildings, highlighting how they change over time. Combined with data from sensors that read environmental conditions and occupancy, we can create an intricate model of how people, furnishings, and environmental conditions interact. These four-dimensional models could become virtual collaboration spaces, available to people who cannot physically be in the same location.
Foster & Partners and Boston Dynamics will continue to push the boundaries of innovation, bringing the technology of the future in the hands of our designers today.
Thanks everyone, and we're open for all your questions.
What an amazing presentation. This is amazing. I had a lot of questions actually. Can I start?
Yeah, please do.
Yeah, I'll start with the latest issue presented. Like the Spot can go scanning, 3D scanning the whole space, and then recognize the data and so on the cloud, and then you can do processing on it. So what if Spot has a perception and can recognize the elements and the objects in the 3D scanning? Do you imagine how the construction future can be? Can Spot has other like jobs rather than just 3D scanning? As the 3D scanning looks, he has a lot of capabilities in understanding the surroundings, obstacles, and so on. Can he do more jobs? Like I'm thinking about the future of construction, how the future of construction can be if the start is just this amazing 3D scanning capabilities. If he can understand more, yeah.
Oh, on the short term, sorry, Khaled.
No, please go on.
On the short term, actually, just this week, Boston Dynamics released a 3.0 update to the software. And one of the things that is a part of that is that he can now walk the routes by himself, as well as more, I think they're very close to doing more integration with the arm. So you could actually, as a part of the arm, plan in one of the actions, part of the route, planning one of the actions being the arm. So maybe in our example, we can ask him to walk the campus at night and open the doors himself and so on. But of course, you can take that a step further and think like maybe he could move stuff around on the construction side as well.
Yeah, so the tool is very versatile. So basically, you can add whatever you would like to it. So they're doing a lot of stuff with security, more things with also with the robotic hands as well, manipulating objects. So this was like our take on it as a start. but it's definitely going to grow more and more in the construction site, and also with more versions, it can handle more weight and maybe be able to move more objects around the site as well.
I think also interestingly, like once it's able to detect the objects, someone like Avier can actually offer their service on the edge where all the computation is actually taking place on spot, especially with the addition of things like extra GPU compute and CPU compute from BD. So Spot can actually have the BIM model, and using technologies and features from Avier could be able to do all the diffs or the deltas in real time, and instead of us having to go and take the scans and do all the registration and everything, you would just get a PDF report at night telling you where things are and where things aren't. So yeah, it's definitely interesting.
So based on these updates, it looks like in the future we can have like a pack of spots, a swarm, where they can work together, and we don't need like engineers on site.
I mean, from what you've seen, we're still a bit far from this, but it's getting there. It's definitely getting there. Especially like when we saw Spot working for the first time, having dealt with a lot of other like mobile robots before, we're like very impressed, because like a lot of stuff like that other robots can really barely do. Spot was doing it like very, very quick and very precise. So I can see how the technology is being pushed forward very quickly. But for a while, it will be a collaboration tool before it was like fully automated on its own. So bit by bit, but we'll see.
Yeah, and regarding when Tarabishy said that the obstacle prevented Spot from just moving forward from the latest point, why didn't Spot just climb this obstacle? Does it has limitations in the Z direction?
There's usually like a lot of parameters that you can set, and the reason behind them is to enforce some kind of safety on Spot itself, but also anyone standing near Spot. So in this case, there is a threshold that you can specify in terms of distance it should leave with any obstacles around it. In this specific case, actually, if it was running the mission with this number set to 0, it would actually attempt to climb it. But in this case, those things weren't really solid. So when it actually did, those things started falling and Spot was about to slide. So usually you would have this threshold at a higher number, like 1 or 2 centimeters, and in that case it would do as it did in the video, where it would just start trying to walk around the obstacle in order to see if there is any way to reach beyond that point or not.
Okay, I understand now. Okay. So other question regarding the scanning. I remember Andrea mentioned that if the internet connection just lost, the whole operation can fail. I got confused why it failed. Can Spot remember where the operation just paused and then continue?
So actually, I think maybe Sherif has the most precise answer for this item.
So for this one specifically, like it's again part of the beta release of Spot. It's a safety measure enforcing you to actually be available on site and following Spot. But recently with Spot 3.0, some of the features that Boston Dynamics added is actually being able to even record the mission remotely. Because now Spot can have like a docking station on site where it can go at night and charge itself, and you can remote to Spot as if you're having this Zoom talk that we're having, and see what Spot is seeing, drive it around, record the mission, and then have it do scheduled missions. This couldn't have happened unless Boston Dynamics had a very strict safety measures during the early release, enforcing that people are always around to maintain safety of the construction site and of everyone on the construction side, and they were able to see all the interactions that can happen around Spot. And through collecting all of this data, now they're confident of the way you can run Spot in 3.0 without needing to follow it around with the controller.
Okay. So it looks it's coming. The future is near. It's so near. So I know, Tarabishy, you had a great interest in machine learning and these kind of applications. So in the age of AI, how do you like imagine the future of construction, human-robot interaction, especially with like a pack of spots? Like if you have a swarm of a spot, how AI can help you? How do you imagine the future of construction?
There are a lot of things that can happen in that area, but I mean, like the point you mentioned at the beginning, if Spot is able to detect the elements that it's seeing around and do specific actions, whether physically or just digitally in terms of reports it's sending back to you, all of those things can be facilitated by integrating different AI techniques on the edge, like on Spot itself. And I think Boston Dynamics definitely see that this is where things are headed, and that's why they are offering the extra GPU compute as an accessory that you can add to Spot and be able to do extra computations necessary by machine learning techniques on Spot itself.
I have a latest question. Sorry, I know I ask a lot of questions, but I have latest question. I can imagine if we have like a voice command alongside with the tablet when you are controlling Spot. Why don't we have this kind of like a voice command where you can help Spot to do its job more easier?
I believe this is already available, like
okay.
Boston Dynamics offer different like APIs that you can utilize to create things like that, because it's also available for developers to extend the features of Spot, and they also have their own implementations of things like that that you can test out.
Okay. Okay, I check if we have any other questions from the audience. And yes, if you have any other questions, you can send it on Discord or YouTube, or at any time I can reach the team and get your answers back. Yeah, I asked you all my questions. Do you have any reflections, Khaled, regarding the future of construction?
Yeah, I mean, we definitely looking more and more into automation, and so to increase safety on site. That's definitely going to happen. And you can see how also we can control a lot of the problems, because right now you don't have to go and do snagging anymore. You will have like the 3D point cloud every day. So you can imagine very easily checking and getting all the problems. And this will make the construction process faster and more accurate as well, and allow us to do more with our designs. So, I mean, for a long time, the construction kind of process have been one of the hardest like industries to change. They've been like very slow compared to others. And now with like all these advancements of using robots in and like complex environments, like it's definitely pushing it further and further quicker. And hopefully bit by bit, this will go also like internationally. So we would see it like in different countries as well, not only here.
Okay, we have a lot of questions in the chat, so I may pick one. Why this is important for architecture? I understand, yes, for scanning and be like a co-worker on site, but why it is so important? Why do we need like Spot on site in construction?
I think it's more than construction. It's also about us as architects learning more about how our building is being used. So of course, when we deliver a BIM model, there will always be some kind of differences between the as designed and the as built, and Spot can help us updating that, at least this scanning sessions. In addition to that, we could also do continuous scanning sessions to understand how the space actually is being used. Like what, if you have certain spatial arrangements, are they more popular than others? And then starting to compare that with other data sources, temperature, humidity, and so on. So it's one part in this, how information about use can add additional learnings to us as architects.
Okay. We have other question like, how do you see this technology evolving? How about the cameras used? Is it LiDAR? And so on.
Okay, let me try to share just a picture so I can talk about the sensors a bit more. I'm trying to find the right one. Share screen, share. So actually, Spot itself have like multiple sensors on it. So it have like this kind of Kinect kind of like scanners that are like close range, and have like maybe 6 or 7 of these all around. And these are used for Spot to when you're moving, to adapt to any kind of close proximity obstruction. So humans, if it's find a box in front of it, the options that Sherif was showing when it was trying to go through the barrier and it couldn't. And these are usually very quick kind of sensors, and they're very crucial to its movement. And then we had the LiDAR as an extra version, and the LiDAR was more for the mission. So when you record the mission once, especially in a space that's changing a lot like construction site, you need as much data as possible from the surroundings. So actually the sensors on Spot, while they can be used for missions as well, in a space like a construction site, maybe they weren't enough. So we had the LiDAR in order to get like much more information about the surroundings. So next time Spot can find its location, right? Okay. So it's kind of levels of it. And then from the LiDAR, we couldn't use a point cloud from the LiDAR for our scans. It was very low quality compared to what we needed. So that's why we added also the scanners that can go down to like 3mm accuracy, for example.
Yeah, but I remember when I used LiDAR in my iPad Pro, the quality outcomes wasn't like clear enough. So how this kind of generated cloud is so helpful when it comes to LiDAR, how this kind of quality is improved so we can use it and can become beneficial.
Yeah, I mean, the LiDAR sitting in front of a Spot also is not like it does it very quickly. So it's not like a super high quality point cloud, but what they do, they have like a lot of models that I'm sure there's like a lot of machine learning happening into it and so on, in order to use this kind of lower quality data, but get a lot of information out of it rather than just what you see with your eyes in terms of quality. So actually the LiDAR is really good for it to find its own location, similar to all the autonomous cars that you see, Waymo and all of these that are now driving just with LiDAR in front and back, basically just and some cameras. The 3D scanner, however, is different. 3D scanner was like you stop, you do the scan, and you get like a super accurate version that's like a gigabytes in size. So that's why we make sure that we have a scanner, or we wouldn't be able to just use the LiDAR data.
With around 3mm precision, Khaled, right?
Yeah, So
for the Faro scanner.
Yeah.
So this is like Khaled said, this is the actual data we're using, not the data from the LiDAR. You kind of don't have access to the data from the LiDAR. It's just used internally by Spot.
Okay. And we have other question, like it's very interesting question about the scanning technology and urban analysis. Can Spot work alongside with drones and other kind of mobile machines and maps on the same cloud? So we can have like a model from a lot of, like if it is outdoor model, or it is just capable of indoors. It can do outdoors as well.
Actually, for the latest version 3, they have the capability of combining multiple robots, so drones and Spot at the same time. Where the drone will do like the overall kind of scanning, and Spot can do like a more detailed one. Because the problem I mean, the drones have their own use, which is they do usually with photogrammetry, just using pictures. So again, it's a lower quality kind of scan, but can do it in massive areas. So you can do like huge terrains and so on. While with Spot, you can't, at this point in time, you can't really have a full-fledged 3D scanner on a drone, because the drone moves all the time, even like slightly, and the scanner needs to be like very still when you take the scan. So yeah, so you can kind of combine different scales. So where the drone does like a very lower quality large scan, Spot does a smaller, more important points, and they can all work in kind of harmony.
Okay. And we have other interesting question regarding the robotic development. And I know Foster's is architectural office, and then Foster's development is an R&D team developing technologies to be implemented somehow in the design and construction process. So how the team is like collaborating in this kind of robotic development applications? Is it in the application itself or being involved in the robotic itself? And how you see this kind of experience, or like, let's say, experiment, how this can be reflected on the educational programs and what students are learning, the future of education and so on?
So in the office, we do a lot of, we try to do a lot of collaborations. So most of the time, either we see an idea that we can try to bring it in, either as a tool or a process of manufacturing and all of that. So we test a lot of manufacturing processes even in-house for the stuff that happens in the building, stuff like with timber and all those kind of things. But most of the time, we try to bring collaborators. So people will come with their own expertise, and like in this, like here in Boston Dynamics, or someone else like other university doing like concrete 3D printing, and we get our expertise, and together we can get like a product that's quite innovative and takes like the best of both worlds, if that makes sense. But we have a lot of, we always look 5 and 10 years ahead, and then we try to get all the technologies that are in the labs and try them early on, basically. So we have, so we get better access early on in the process.
Okay, I have a question. I clarify part of the question for all of you. If, like, I'm a university and I'm developing my educational curriculum, how these kind of experiences can be implemented? Does the students need like to have a minor in computer science, or just what we have in the architectural schools is enough, and so on? How do you imagine the future of education? So from your perspective as an R&D department, and you have this kind of such great collaborations with other disciplines like robots and so on, what's your recommendations for a university to develop its curriculum? How my graduates can, if I'm a university, join like your team? Does they need a minor in computer science, or just being an architect is enough, and so on? Does the office prefer computer scientists more than architects? How you imagine and how you see yourself as an architect, but like after these kind of experiences, like planning for the future for the students?
I think one of the interesting things about most of the people in our team is that they had traditional architectural education in a sense, and all of us also worked for a while in different firms and so on before we joined the R&D team in Foster. So in a sense, we were exposed to the traditional process and its downsides, right? And one of the things we're always trying to do is how to make this whole process, design to production, more seamless, efficient, and better for the designers in the office. And how can we, in a sense, facilitate for them taking more informed design decisions throughout the whole process? And I think this capacity to do that, like, I wouldn't say, for example, my education didn't allow me or help me to be in this position today, because I think my education is what actually allow me to be in this position today. I truly think that you don't really have to integrate all of those things in a bachelor degree course, like fully integrated. But I guess it's definitely useful opening the eyes of the students to what's happening outside the traditional way of doing architecture. I guess fully integrating it would be better placed for a master's degree course or a continuing education course. But I think it's very essential, like looking at the traditional process and living through it to see what needs to be improved, right? If you don't know what needs to be improved,
to define the problem itself.
you don't.
Yeah,
Yes,
yeah,
yes.
Yeah.
But even within our team, there's not a one shoe fits all. Like all of us have kind of a slightly different focus. Some of the team members have an interest in robotics, have interest and experience in robotics. Some have experience in machine learning. Some have in physical computing, IoT. Some are more on the end of web application development or plugin development. So there's a very large, like even within our R&D team, there's not like, you can't just teach us one thing and then hope you fits, because it's a very, very right. In the same way that some architects specialize on airports and so on. It's a very wide field, even.
Yeah, so you mean it's like an experimentation, and you can have like a slight understanding of all these kind of experiments, but you must be specified and skilled in one domain of this slot. So all the members in the same team can cooperate and collaborate together to have one project, something like this.
Yeah, but also you need to be flexible enough to jump outside of your specialism and support projects on various things. So I think that's where the architecture backgrounds come in, because an architect, they are good at many, many things, and they're also good at learning many, many new things for a specific project. And that's an amazing skill that we are getting taught.
I think that's a very good point that Anders raises. Like the structure of any curriculum in general has this fake sense of this is all you need to know, while the important thing is to like encourage and somehow teach students how to be more fluid with picking new things up and just using them and integrating them and curating them in different processes and workflows. And like, if there is one single trait I believe students need to have, it's this, because it's the only thing that would allow you to jump from, like Anders said, like jump from one team to another, jump from developing an in-house tool to assisting a design team with something. If you don't have that trait, you will find it very hard to do all of those things.
Okay, so let's ask other question. If I ask myself how I define myself, I'm like major architect and like a minor fabrication specialist, something like this. But from your side, how do you imagine your job has become? Do you think you still like measure as architect, or measure as a researcher and deep learning scientist and so on? So because the question is, if a student asks me how I can start this kind of, so I have to give him recommendations. So how you define yourself? Are you defining yourself as a research scientist with minor architecture, or like architect with minor as a research scientist?
I mean, look, I don't have anything against like being a specialist in something. It is definitely needed, and some people are more comfortable with that. But I would say, aside from all of us in the team having specialty in specific aspects of architectural and computational research, we're also very open-minded and fluid in terms of picking new things up and seeing how they can solve problems. If I see that, and I guess it's also part of what's interesting about being a member of such a team is that you're always on a daily basis seeing the how different people with different interests look at problems. And if, for example, I have a problem and I'm discussing with another person with a different specialty in mind, and they tell me like, it actually could be interesting if you use this specialty to try and solve your problem. If I don't have the ability to just like take my specialty off and attempt to like use their specialty and start researching and learning something new to solve the problem, I don't think I would fit in this team.
Yeah.
It's
So I can
major-
define you as an architect with minor as a research scientist, because like this kind
it's
of
a measure
being
of problem solving.
Yeah, problem
Then a
solving
minor,
skills.
minor
Yeah,
in programming.
yeah, minor in programming rather than what you're saying, like a research scientist. I guess it's more about problem solving and software development within
Yeah, I mean,
interest
for us,
in architecture.
architect won't like really will be the best fit, because actually we have like an artist in the team that was also was doing a lot of computation and joined the team, and he's working on architecture projects, solving architecture problems, but he's usually focused on the specific problem that needs to be solved using data. So it doesn't matter for him to be an architect that understands spaces in the way that you've been like trained. So it's this is a big discussion, because we have been having discussion inside the team, trying to figure out what we should call ourselves actually, because we wanted to update our titles, and it was like a big problem. Like everybody had their own view about it, and it was like a major discussions that end up not going anywhere. So it's kind of, it's building up, and but we really, even us, we're really finding it hard to find a definitive like kind of title or measure that we can work on.
So can you state just few recommendations for the students? If I'm first year student, should I focus, as Tarabishy mentioned, on my bachelor education, or should I keep on the side like this kind of interest learning programming and so on, or should I just keep it
both
when I graduate?
Yeah, both. Like it's learning processes. You don't have to learn like just language. I mean, it starts by learning a process of optimization, doing high performance design, all this kind of these like really make you look at problems differently. And even like architects have been like classically trained in our office right now. When we go, they come to us and say, okay, we need an optimization for this and this and that. And this is because they have seen it and they know how the process works. They don't know what's happening in the behind in the code. But if they don't understand the process, it becomes a clash. So you'll go to an architect and then you tell them, oh no, I'll give this to a computer and then it will figure out the angle of reflection and we'll do this in the facade, and you will look at you as if like you're talking.
Yeah, I guess something we've always been clear about, especially in our team, like there's no need for the whole company to know the skills that we know, right? But at least they need to be informed about what other processes and what other workflows can be used in order to do their tasks. Because if you don't have this knowledge about how things can be done, you will just keep focusing on one thing, which is the one thing that you've learned at school, or if you had the opportunity of working in a nice office and they pushed you a little bit to start looking at things differently, that's the only thing you will keep doing over and over again, right? So yeah, I think definitely focus.
It's about exploring the possibilities. Like,
yes, definitely focus on what you're being taught if you're like doing a bachelor degree, but also look at what's happening outside that.
But also, I think actually the most important thing is do what you think is interesting, because you are getting taught a lot of things, but whatever you want to learn outside of that, that's based on your interests. And that's how you get good at stuff, because that's how you learn new things. And if you're not excited about, you shouldn't start learning computational design or programming if that's not you, and because some people just do it. It's finding what you are interested in, what you're good at, and making sure to be as good as possible at that.
Okay, perfect. There is a common question these days, like how COVID impacted your research and work and so on. But I'd like to ask it like, if we can work from home and we can have these robots on site, what we learned from this time, what lessons learned, what obstacles we have, how the office of the future would be, as you spent like 2 years working from home. So your imagination about the office of the future, does it change it, or it is still the same? Do you prefer it be like in groups in the office, or it can be like on the cloud? And so on, these kind of questions.
Maybe before asking, like replying to that specific question, we may actually mention a couple of dates during this presentation, and some of the scans we were showing you were from late February and early March from last year, and we had a quite large number of scans planned, and we constantly had to change our schedule and kind of update what we wanted to look at, because last year changed, and I think I just wanted to point that out. Maybe Khaled, you can tell a bit about working from home.
Yeah, I mean, of course, it was like very stressful from the beginning, but I think everybody learned now that you don't have to be, doesn't have to be face to face for everything. I mean, the office actually did quite well during the pandemic. In the end of it, it was one of the most successful years we had. So I would assume actually kind of it worked fine. So it's definitely changing. I mean, the thing is, the pandemic also pushed a lot of technologies forward, like the video conferencing, VR meetings, all this kind of stuff. Like it's really was pushed like 3 or 4 years ahead when what was happening. So all these tools now that are being developed will maybe allow you to reduce again like the need for meeting face to face. So a lot of it, we from our team, we meet face to face, sometimes socially, rather than just for work. So we are like in meetings all together, but then we can maybe go out and meet each other one day just to catch up. So this is definitely going to change with the tools being upgraded as well. So like probably a hybrid model looks like the way of moving forward, the way I see it.
I think one of the most important lessons or things to remember is, and it was proven by what happened the past 2 years, is that we have a very high capacity to adapt to change. Like the firm continued working, continued submitting, continued meeting deadlines. We took over even more projects than before, and everything was happening from home. A lot of people doubted how things can keep going the way they are with that change, but everyone ended up participating to having things continue working the way they were and even better than before. And to Khaled's point, like a lot of things that we've been looking at inside the team as aspects of research, suddenly from the firm became, no, we actually need this like in a couple of months to start using it. It's not a research demand anymore. It's something that we need to apply to our business and our business decisions in the next couple of months. So it's been interesting, yeah.
That's like the future. How like the future architect should be flexible enough to like maneuver these kind of obstacles. So working from home wasn't an obstacle, but it just like a daily challenge as you have in work, like developing something like this. So it's easy to find solutions. Okay, that's perfect. I have, yeah, we have a lot of questions. If we answer all these questions, we will take forever. So do you have
to the last question, should all new architects be familiar with the power of programming? the follow-up comment, I definitely totally agree with, not as an expert, but at least as a way of thinking. I totally support that. You don't have to end up being like someone who does what we do, but it's definitely useful for anyone in any architectural practice, or I would even say any practice, to have basic understanding of programming and the way programming makes you think about how to solve problems, which I think is the most interesting thing to learn or to take out from this journey of learning a new programming language.
Well, I have a view on this as well, because I see all the children now are learning coding at school, right? So there is going to be a new generation that's going to be in every field, like a doctor that knows programming, technicians that knows programming, and so on. So this generation is going to catch up with us very soon, and then we will be quite obsolete if we don't have some sort of programming like knowledge as well. So like, keep a look in the maybe next 10 years, because when this generation arrives in every field, this will also change the conversation a lot.
Okay, perfect. We just received a question about the educational learning opportunities created by Foster's. I remember that Foster's has an educational foundation where students can go there and take workshops, but I don't know if they are working like they have a schedule for along the year, or it's just announcement. I don't know if you have any reflections.
No, I mean, the foundation have some workshops and so on. It's separate from the office, and it's based in Madrid. But they do a lot of educational collaborations. There's also some interns in the office. A lot of the, I mean, most of our team is actually teachers as well. So we in UCL and different universities. So that's how we also maintain like a relationship to academia and students and so on. So the office actually allow us to go and teach, which is quite nice as well. But again, there's interns. They're trying to increase interns in the office as well, and this is also an interesting opportunity for people to learn, and this kind of presentations that we do as well in all fields that office is encouraging more and more.
Okay. In the presentation, I saw like you guys say that like exploring the physical characteristics of a material is something important that the team intended to do along the way while developing something. So when we moved working online from home and so on, how this kind of physical experimentation getting implemented through the process along the way? Like people are working from home, how they do this kind of physical material testing exploration, as in the educational in the universities, in the educational process, this was a hustle, how we can teach the students how to explore the materials and integrate it with the design process and so on, even we are like working satellite from homes. So how you guys tackle this kind of problem, experimenting physically, and then continue discussing and working on development based on this kind of physical experimentation? Do you have this kind of experience?
We had the same problem as well. I mean, some of us had to take like some VR headsets to their home and test stuff and do like some stuff with AR in their gardens, or like robots and their driving around furniture, all this kind of stuff. So for us as well, it was like a big hassle. But the way we see it forward is we are trying to more and more in the office, instead of having like spaces for you at desks that you sit on and so on, is to have more collaborative spaces that you can then meet with other people there and do some stuff on like a physical model. That you're always going to have that. And I have seen also a lot of because we had a manufacturing masters in the UCL that was like also hit quite badly. So most people were working from their home, and they were talking about robots.
So you mean it's still a hustle? Yeah, there is no like perfect strategy for tackling this kind of problems.
No, you definitely can't.
Not yet.
You still have to be physically there.
Even using as like a pack, a swarm from spots where you can
Well, I mean,
control
we talked
them from
about
home.
VR headsets and like some touch simulation kind of technologies, but this still far still as well. But you never know in like 5 years what's going to happen, but we'll see.
Yeah, I can imagine if you can virtually control them from home, as the doctor controls the surgery using some robotics and do the surgery. Yeah, so maybe we can do this kind of physical experimentation from home. We have received like a latest question about space architecture and lunar habitats and this kind of exploring the space, having habitats for humans, the future of the city in this kind of harsh environment and so on. So based on this kind of very advanced research and futuristic applications, how do you imagine the future of human habitats on this kind of space?
So we have, I mean, to be honest, this was like also a research conducted by a sister team. So it might be better equipped to answer it. But I remember when I started working in the office and they're doing the lunar one, they were talking about all the 3D printing with dust, and that they have like some samples somewhere that they're trying to print with, which was like very exciting. So, I mean, this is quite an interesting topic because, again, as I told you, we don't look only about the project. We don't look into the projects that we do, but we look also into the future and how is going to be, how the buildings are going to adapt and so on. So we learned a lot, I think, from these projects in terms of 3D printing, in terms of like autonomous construction, how to use like materials that are very different from the materials now and how to adapt to all these kind of things. So in a way, it also kind of had an input in our design process in the end. Not only in the design process of the buildings we're doing now, not only for the ones that we're trying to do like outside Earth and so on. But in terms of like details, I won't be able to answer much.
So it looks like we have a future session to plan.
Yeah, definitely.
Yeah. Thanks for your time and thanks for everyone's time. We don't have more questions. Yeah, it looks we have comment. Do we have any comments from YouTube? Yes. Thank you for much detailing. Yeah, thank you. Yeah, it looks people are so happy and excited, and me as well. I'm so happy to have you today. And thanks for your precious information and sharing this knowledge. I'm looking forward for the discussion to continue. Gustavo, do you have any reflections you would like to share before we wrap up?
Well, I just wanted to say thank you very much. I'm sorry that I'm full of questions. I'm letting Ahmed, who's an esteemed colleague, I want him to definitely enjoy the fruits of this. But a lot of my questions were, if you are on the cutting edge of this type of research, and you are this new type of architect slash, I would say, kind of computer researcher, scientist, let's say, how would you try to align more research dollars to facilitate what you think the evolution of the profession is going to be? So would that be more funding from at a policy level from universities or countries to have architects be exposed to more engineering and sciences, and vice versa? Because space is not going to be limited to just physical. There's also metaverse issues. There's also interface issues. So how does your team really apply your expertise to these new emerging fields?
In terms of being a new type of architect, I wouldn't say it's that new. I mean, in UCL, for example, the course we're part of, which was founded by Alistair Turner, it started out, I guess, 20 years ago, where it was the first of its type as a course mixing between computer science and architectural education. So, and the course, like a lot of people have graduated from it. I think it's more from a business side. Businesses recently starting to realize how essential it is having people with such expertise as part of their team, and the type of work they can do in making the whole, again, design to production process more efficient, more informed, and more streamlined. In response to the second part, I guess it's definitely interesting integrating new aspects of education and integrating them with architectural education. At least for me, my education in Egypt, I wasn't an architectural designer, I was an architectural engineer. So in a sense, the curriculum already had some of the things you mentioned integrated, in terms of having more exposure to building technology and engineering rather than just architectural design. And I would say, and agree to what you just said, is with new topics like metaverse and so on, how will this change from what kind of different disciplines should integrate within the architectural education? And the things you mentioned should definitely be there in terms of human machine interfacing and programming knowledge and so on. All of those will be required in coming years when we start focusing on building virtual experiences that in a sense might even replace our physical spaces.
I might just comment on the kind of funding part. For us, it's always interesting whenever like two fields collide. This is usually where you find also funding. Whenever you get like a roboticist with an architect, or we're doing other stuff as well with machine vision, all this kind of stuff. You can, whenever you start doing something outside the comfort zone of an architect, it's usually much easier to get funding as well. And we have a good model where actually we try to find governmental funding, and we contribute with our time, and then some other fundings from, because as well the know-how is quite important. So everybody tries to contribute their time in, and then we try to reduce the funding as much as possible in order to just build prototypes and tests and so on. So from what I have seen, is always whenever you try to collaborate with something that's another field, you always like have a good chance of finding funding and moving forward with your idea quite quickly, because this always interests all the kind of governmental funding kind of research initiatives and so on.
I just had one last question. What would be a grand challenge for your Foster's partner? So let's say if the world government comes in and says, hey, Foster's Partners, we need you to solve a problem, and it's going to challenge all of our team. What is kind of a problem that you think would require your best, but also an evolution of the field? Would it be something like climate change? Would it be something like, you know, space architecture? What is a problem that you would want to try to grow with in the next decade?
That's quite a big question also. Like,
That's
I mean, I would say I will answer it from a personal perspective, because I can't answer for the whole office, definitely. But I think something like also waste, which is a big, massive problem in the field. We try to tackle it as much as possible in our buildings in terms of sustainability and material using, and reduce like the waste from the construction process as much as possible. And this, a lot of it happens as well with trying to use new technologies that like reduce as much, like uses the material in the most kind of to its most ability, let's say. as well. So I'm assuming like something like a sustainability point will be like the measure. I mean, which we are definitely part of already, but I mean, we maybe need like even a bigger push towards it in the future as well.
If I
And
have to answer, if I have to answer this personally, and again, like not as a representative of the office, I would choose something way simpler, which is just housing for everyone. Housing for everyone. I mean, we're talking about, again, like things related to technology and advancing the whole industry and so on, and they are great things to look at and important and useful, but still the basic thing is housing for everyone.
Perfect. Thanks.
But you,
housing as a human right. Just
sure, you have also a different answer, since you have like a different background as well.
I think something within sustainability, climate change is a very interesting topic, because again, that has to be addressed by so many disciplines, by engineering, by architecture, by sustainability, but also by computation and data, which is maybe where we can help a little bit. So looking at systems and so on. So I think there's enough grand challenge to work on. Yeah, at the moment now we are just running around with a little robot dog and doing a few scans. So yeah.
I know I am not from Foster's side. I'm from Digital Future side, but I'd like to, like, if I were a Foster's team, as Tarabishy said, if I am like talking about myself, if I were Foster's team, I would like think of the future of education and how education can be affordable for students, high quality education for students, especially in rural areas and very far places that is less privileged to high quality education. So they can in the future build a better future for their countries, for their continents and so on. As like, I believe changing the world is mostly based on education and research. When you have like a very dynamic, energetic, futuristic education, this would help everyone to build their country and so on for a better place. So if I'd like to invest this amazing team in something that will change the world, this definitely will be education, and how to make a high quality education affordable for everyone. And this was like why we invited you all here today to share your expertise and amazing knowledge with everyone. I'm also happy to have you today answering like all these questions and share this knowledge. So I'm happy. I'd like to have like the next session on lunar architecture and this like harsh environment. What the future of human habitats will be and so on. So please, for our audience, if you still have questions and reflections, you can share it on YouTube and Discord the channel. And I believe you can reach this amazing team on LinkedIn and through our channel. It's fine. See you all next event. Thanks.
Thank you very much.
Thank you.
Bye.
Bye.